What's going on, 7th grade science students? Here's what we're going to be doing. Actually, let me show you folks real quickly my computer or my web camera. I'm allowed to use my web camera. I just want to do low quality, start sharing. You guys should be able to see my computer screen pretty soon. Or not my computer screen, but my face. Webcam meeting. Default layout for everybody. What's up? It's low quality, so I'm probably all pixelated. But I just want to show you guys really quickly. On Wednesday, we're going to do Nerf gun labs. Actually, I got a bigger one. What up, my 7th grade students? We're going to get started on this thing. We're going to be doing some Nerf gun labs on Wednesday. We're also going to be breaking some bridges, hopefully. And we're going to be doing a few other things, making bottle rockets, and then we're going to get started up on other things. This week, I'm going to close off my webcam. I just wanted to show you my guns. Hi, Ava. Ava, I need to apologize to you. I got your email. I wanted to say I'm sorry for not getting back to you on your messages to me. I will make sure to put every effort into that. Okay? No, it's not okay. It's not okay that I don't respond to you guys. I apologize if you feel that way, and I will definitely make it up to you guys. So, here's what we're going to be doing today. I'm going to show you my computer screen. Today, my plan is to cover bottle rockets, just the introductory to it. And I'll be honest with you, we've been on this big stint for the Science Olympiad. We've been building bridges. We've been shooting Nerf guns and air trajectory. We're going to be covering up bottle rockets today. And then on Wednesday, we're going to do a lab. And after this week, I'm done. I want to get into our actual curriculum. I really feel bad about doing this big push for the Science Olympiad thing where we're doing all these projects. I think that they're very fun projects, to be honest with you, but I feel bad that I'm not doing the biology stuff that you guys need to have in 7th grade and the and that kind of stuff. I've been focusing mostly on engineering and physics sciences. And to be honest with you, that's my cup of tea. That's what I normally do. But all right. So one of the things I want to do with this class is we're going to be building bottle rockets. And I want to dissect something as well. I want to start getting into like the biology and that kind of stuff. But let me finish off the rest of the stuff for this week because this is kind of important stuff. I think it's fun and cool, really stuff for us to do. I want to build a bottle rocket, and so I'm basically going to give you your lesson on introduction on bottle rockets. I'll let you guys build them at home, and then one of these days you guys are going to come in for a lab, and we're going to test all of these things and shoot them after I build the base for it, and it's going to be pretty cool. All right. Michael, feel free to ask me a question after this if you have to go. I'm totally fine with that. Read your... Oh, yeah, I turned off my webcam because I want to show you my computer screen mostly. This is the rules for the bottle rockets that we're going to be building. I don't know, has any of you built this kind of stuff before? A water bottle rocket? Yes, I'm recording this. Okay, you have? All right, cool. All right, so what we're going to do with our water bottle rocket is we're not just going to shoot it off, but we're going to put an astronaut in there. We're going to actually have an egg astronaut on the top of it. And then we're going to, actually, Ava, I'm going to cover what a bottle rocket is. But what we're going to do is we're going to build a bottle rocket, water bottle rocket, out of a 2-liter soda bottle. And I will show you folks how to build it and all of that kind of stuff. We're going to build it out of a 2-liter soda bottle. Your challenge is to put an egg in the top of it or in the bottom of it or wherever it is you want to put it. And it has to be something that has a payload of an egg. And then that bottle rocket has to stay in the air for the longest amount of time. And obviously, if it's staying in the air for the longest amount of time, that probably means it's going the highest possible it can possibly go. You might want to attach a parachute and all of that kind of stuff. Your goal is to get that thing in the air for the longest amount of time and have the egg survive. The way you win in this thing is you need to have. I think you need to launch it twice, and both times need to survive the launch, and then basically ties within Tier 1 and Tier 3 will be broken by the greatest amount of time aloft by a single rocket. So basically, you want the thing to be in the air for the longest amount of time, and that would be the competition. That's how we're going to run this competition. Are we cool with that? So this is kind of a preview of what's coming up. So what do you need for a water bottle rocket? Actually, Ava brought me up a very good question. What is a water bottle rocket? All right. When you think of a bottle rocket, you think of some kind of firecracker attached to a stick inside of a glass bottle that whistles and goes, pew, pop. Or at least that's what I remember when I was a kid. I don't think you kids get to launch bottle rockets anymore, but I did. It was cool. All right. So what is a water bottle rocket? A water rocket is a source of great entertainment for many years, and it's usually made of a 2-liter big bottle of plastic, a plastic soda bottle. And then what you do is you fill the soda bottle with a certain amount of water. And what you can do is this plastic is made of polyethylene terephthalate material, and as most plastic soda bottles used today was introduced back in the 1970s. What you can do is you can fill it up with water, you put some air inside of there, and it basically pressurizes the system, and then you let it go. And what happens is all of that water will shoot out the bottom, and it's kind of like if you were to stand on a skateboard and you were to jump off the back, what will happen to the skateboard? No. I'm asking, if you're standing on a skateboard and you were to jump off the back, what happens to the skateboard? The answer is it'll go forward more faster. Yes, I totally agree. It will shoot forward because you have a large mass jumping off the back, right? So that's kind of exactly what's happening here, is the water in here is shooting out. It's like jumping out, and then the plastic bottle, that's kind of like the skateboard. And it's shooting forward as the water flies out of it. Kind of an action and reaction thing happening there. All right, let's talk about the timeline of rocketry. Let's talk about like the different parts of rocketry. Let me give you a little bit of a history of it. All right, so there's back in 300 BC, there was this dude named Aulus Gellius, Aulus Gellius. Let's see if we can find a picture of him. I'm going to basically teach you through images today. Aulus Gellius, he was a Roman writer, and he talked about this. He wrote this story about this guy named Archytas, Archytas. And Archytas, in the story, made a pigeon that he would amuse people back 300 BC in the cities of Terretium, which is a part of southern Italy, with this pigeon that he made, and it was basically steam would fly out the back. Now, this isn't necessarily, this was actually found in a story written 300 years BC, so you would think that, like, wow, they had rockets way back then. And yeah, that's kind of what they did. And that's kind of the first kind of beginnings of, rocketry, and the first time we can find in history where you have rockets portrayed. 300 years later, there's this guy named Hero of Alexandria. And it's not Hiro like the Big Hero 6 guy, but this one is Hero of Alexandria. Hero of Alexandria, and he came up with this. It's kind of like it's kind of a rocket. It's a spinning device, right? And so what he would do is he would put water inside of this brass circle, or it was like a sphere, a water basin on top, and he put a fire below the basin, and so then the fire would heat up the water inside, and then the steam would fly out, and then he would have these two L-shaped kind of pipes attached to them, and then the steam would fly out like this, and then it would cause this thing to rotate in a circle, and that was his invention. Pretty cool, huh? Anyway, that's 300 years BC. That's pretty crazy. All right, so now we're advancing in our timeline to 100 years AD, and we're going over to the Chinese. Let's see. Wu Qing Song Yao. All right. So, when the first... No, Seamus, you didn't buy a Nerf gun for nothing. You're going to use your Nerf gun in the lab. I'm just bringing some extra Nerf guns for those of you, the students who didn't buy them. And I apologize for making you buy a Nerf gun if you didn't want to. All right. So let me go on to the rockets. So 100 years AD, the first bottle rockets kind of appeared. We're thinking that it's the Chinese that kind of came up with this idea where they started it off with making gunpowder. Now, what the early Chinese kind of experimented with is gunpowder firing out of tubes, and what they would do is they'd take bamboo and attach them and put gunpowder inside, and they would make like an arrow out of these things. And this fire arrow would have better range than ordinary arrows that were shot out of a bow and arrow, and so eventually they found applications in battle. And so what they would do is they discovered that these gunpowder tubes can be launched by simply igniting the powder and releasing the tube, and a bow was not even used to keep the arrow in the air. And so thus the first rockets were born. The first recorded use of fire rockets was in 1045 AD by an official named Sim Kyung Liang, wrote a complete account of Chinese gunpowder use in what he called the Wu Qing Sung Yao, which is basically his military book on, Chinese military book on gunpowder. And that was about 100 AD. All right. One of the places where rockets were used was when the Chinese were defending against the Mongols in the Battle of Kai Feng Fu. And here's a picture of a Chinese soldier launching a fire arrow. Let's see if I can get some other pictures. So here's an old picture of Chinese, of this battle in 1232 AD, where we see pictures of the rockets actually being used in China. Like in Mulan, yeah, like in Mulan. All right, cool. So basically, the Chinese were attempting to fight off the Mongol invaders, and so they basically made all these rockets. And we weren't necessarily sure how well these things worked, but it looks like it worked pretty well, from the picture at least. All right, so later on, there's this dude named Roger Bacon. Let me see if I can find a picture of him. It's an old monk from about the 13th century, and he worked on improving, this dude named Roger Bacon, he worked on improving gunpowder, and he basically increased the range of these rockets. Later on in France, there's this guy named Jean Froissart, Jean Froissart, Froschert, and he found that you can basically launch. Actually, it's probably Jean or whatever. Jean Froschert, and he found that you could launch rockets more accurately if you launch them through tubes. His idea was basically the precursor to the modern day bazookas, which is what a bazooka is. It's basically a rocket being launched out of a tube. Later on, there's this dude named Johannes, Joanes de Fontana, from Italy. And that guy, Johannes de Fontana, made water rockets where he basically made one of the first surface to air, or not surface to air, but water to ship torpedoes. And I think they even explored this on Mythbusters at one point in time. I don't know if you guys remember watching that stuff. Class is over at 11:15. Man, I don't have any time. I'm always running out of time. I apologize. All right. Anyway, let me go over what I want you guys to do for the Rocket Lab. No, I'm sorry. I keep running out of time, and I shouldn't. I just wanted to give you guys some history. But give me a second. I'm going to try to finish as much as we can, as quickly as I can. So let's compare the bottle water rockets to the actual rockets used by NASA. Our rockets have a nose cone. Theirs has a nose cone. We both have payloads. And this is an old rocket. Their rocket is much bigger. Ours is 30 centimeters, and theirs is going to be about 365 feet. That's as tall as a 35-story building. There's a propulsion chamber, which is our 2-liter bottle of water. There's a nozzle, and there's fins. So we basically have a picture of what a NASA rocket looked like. Let's look at the parts of our bottle rockets. Yeah, I know, theirs is much bigger. So I might go a little bit late, not that long, I promise. Okay. Water bottle rockets consist of the following parts. A nose cone. This nose cone gives you the ability to be more aerodynamic. Exactly, Seamus. The payload section, which is an important part because we actually need a payload section in our bottle rocket because we need an egg. The body is actually the propulsion system, and this is the actual rocket part. The nozzle would be, well, it's built into the body of our 2-liter bottle, which is basically where all of the water gets funneled out of. And then the fins, you can add fins to kind of stabilize the flight of your rocket. Okay, here's what we're going to do in class. And so Ava, pay attention because you guys keep or not you specifically, but I want to make sure you guys pay attention to what we're doing in this lab today because I'm going to show you how to do it. And then basically all you guys got to do is actually go in and do the work for it. Got it? All right. So I made a lab called Lab Bottle Rockets. And I'm going to take a look at it real quick. So what I want to do is I want to figure out the exact amount of water I need to fill up the bottle rocket in order to make it go the highest I possibly can go. It can possibly go. So I have a 2-liter bottle. Would you recommend that I fill it up with 2 liters worth of water and then try to pump, air into that and then use that? Do you think that will go really far? See, I say no. And the reason being is because if you fill up a 2-liter bottle of water, what's making this rocket go is a mixture of air and water. Does that make sense? So if you have 2 liters of water, you'll have a lot of fuel for the thing. There's a lot of mass going out, but you won't have a lot of air to be able to put inside of there. You see what I mean? All right. Would you recommend not filling it up with any water? No. Okay. Here's my question. Do you think that, if I have a 2-liter bottle of water and I fill it up exactly halfway, do you think that will make me go the highest? No. All right. See, the answer is I don't know. I don't know. And so I figured, you know what? Before we build our rockets, I would like to figure out how much water we should put inside of the 2 liter bottle in order to get the highest amount of stuff. And so one way we can do it is we can test it. But before we even test it and build this stuff and test it over and over, I'd like to actually use some simulators. So there's this dude who built this simulator, and it's pretty cool. He has all of this, you put in all of this information into here, and I am telling you the exact numbers I want you to use. So let me just pull this guy out. I want to show you guys how to use this thing. I'm going to make 2 screens right there. All right. So pay attention to this, all right? So I would like for you to use a 2-liter bottle. This is the number I want you guys to change. The pressure is going to be 413.685. I know. I have a very specific reason for that. Actually, you know what? Let me just check real quick. 60 psi to kPa. I'm just checking something. Kilopascals to. No, I want to go from psi to kPa. Let me just make sure I'm doing something correct over here. psi to kPa. All right, 60. Okay, good. Yeah, 413.685. Good. All right. So I'd like to use 413.685. So this is what you need guys to put in. This is going to be due at the end of the week. It's not really that hard. I'll show you guys what to do. Put in 22. Put in 16. Put in 110. Good. 0.3. Your dry mass, I want you to change to 150 grams, like that. And then 0, 0, 0, and 1. Good. Start simulation. So what this thing is, it's going to crunch all of these numbers based off of very complicated equations that this guy used, and he's going to tell us the answers to a few of these things. So he has information like the burnout. And the burnout is basically, the burnout area or time is basically when all of the water is leaving the rocket. So when all of the water has left the rocket, it will be moving at 39.9 meters per second using the parameters that we chose. It will also have an altitude of 1.5 meters, not that high. It will take 93 milliseconds for all of the water to leave that thing. Here's the important pieces of information I want you guys to use. It will be going, the actual apogee of the rocket will be at 47.12 meters. Now ask me, what is apogee, Mr. Dalday? That doesn't make any sense to me. Is that like a gangster apple? No. What it is it's basically the highest height, the tallest height that the rocket reaches. It's the highest the thing goes. And apparently this rocket goes to 47.12 meters. Cool? Does that make sense to you? Okay. I also want the crashdown speed. I think this is an important piece of information. This is basically the speed at which the bottle rocket will hit the ground at. And apparently with this setup that we have up here, with all of this parameters that we put in, it will hit the ground at 23.8 meters per second. And then the time flight, that's pretty self-explanatory too, is how long will the thing be in the air for? 6.27 seconds. Cool? Now here's what I want to do. No, not 3 minutes, only 6 seconds. It's only going to be in the air for 6 seconds. And then it gives you a bunch of the graphs, which you can take a look at, and it's pretty cool. But here's what I want to do is, I want to rerun this simulation, and I want to put in all of the different volumes that I could put in. Like we thought that if I put in, I asked you if I put in exactly 1 liter, will that actually give me a really good, that give me a really good height and everything? And I don't want to have to go through and put in each, change this value every single time. So here's what I'm going to do, is I'm going to have the class help me out with it. So here's what you have to do. I want you to open up this Google spreadsheet that I made. Do you guys see it? All right. Now, all you have to do is, let's see, open up the Google spreadsheet that I made. And then all you have to do is put in your name. So let's say, since Jonathan's answering all the questions, I'm going to do one of Jonathan's answers for him. All you got to do is put in your name. So let's go, Jonathan, how do you spell your last name? R-I-D-D, Ridskjold, yeah? R-I-D-D-A-R-S-K-J-O-L-D, comma, John. J-O-N. I'm just going to put it like that. So all you got to do is find one space that no other student has put their name in. And you put your name in it. And then what I want you to do is John, I want you to run the simulation with 0.05 for the water volume. So all you got to do is go into the water volume and type in 0.05. And then what I'd like you to do is make sure you keep all of these other numbers the same as what I originally put in. And you can find all of that information up on top over here. So you use, 0.05. And here's what I want you to do is see this data right here, 15.95, 16.2, and 3.61. All you got to do is go to where it says the Apogee, and you type in 15.95 and 16.21, 16.2, or 16.2, and 3.61. And that's your calculated time. And as you fill this in, that data point will appear right there. So I want the whole class to basically do this. And John, I did one for you. I already did one of your data points for you. You can do, I want you to do 2 more. I want every student to do 3 of them. Is that complicated? Does everyone understand? And the link is already in the quiz. The link is actually right here. It's already in the thing. I say open up this thing, and you just click on that and open it up. Got it? Do not overwrite anybody's data. All right? Also, you need to put in your information on the in the questions, and you'll get points for them. So your answers are like, Jonathan, your answer would be, what was the water volume that you chose for your first data point? Well, I forced you to choose 0.05. And what was the actual apogee? Well, you type in 15.95 and 16.2 and also 3.61. So it's almost like you're typing in the data twice. But it's not really that hard into the quiz. And then you answer the same amount of questions for the second data entry and the third data entry. And all I'm doing is I'm trying to get you guys' help to make a graph that will tell me if I put in this much water, this is how high it will go. Or if I fill it up with this much percentage, this is how high it will go. And I don't want to sit there and do all of the different percentages. I don't want to do all of these different numbers over here. So I'm asking you guys to do them. Got it? Any questions, comments, concerns, vomits, etc.? So you can choose any 3 you want. Preferably, I'd rather you choose things that are far apart. I did like 5 of them already. So you can see my name. I already did Mr. Dalday, and I did this one, and it came out to these numbers, and then I basically want you guys to do 3 more. This will be due, let's say Friday. So it's not that hard. You get like 12 points, free points for it, and it's due on Friday. That's it. All right? All right. I apologize for going over time. On Wednesday, here's what I want you to do. Bring in your Nerf guns. We're going to do something cool. And I'm going to wait around. I'm going to stop the recording. I'm going to wait around and hang out in class and answer any questions. Ava, I'd like for you to ask me the questions that I'm not answering for you specifically. Isaiah, you keep calling me, and I want to make sure I answer your questions as well. Okay?